Hello students, welcome to the new chapter of science. The chapter is gravitation. So students, this is the first session of this chapter. In this session we will discuss about what is the gravitation and the universal law of gravitation. So class, let's start our session with the gravitation. To explain the concept of gravitation, I am going to play a video. Please watch that video carefully.
When an apple fell on Newton's head, he figured out that the earth exerts a force of attraction on all bodies near its surface. The force of attraction exerted by the earth on any other body is called gravity. Gravity is what brings things down again when we throw them up. Like Earth, all bodies in the universe attract each other. The force with which all bodies in the universe attract each other is called gravitational force. The revolution of the moon around the Earth is also a result of gravitational force, which acts towards the center of the Earth. Such a force exerted on a body moving in a circular path that acts towards the center of the circular path is known as centripetal force. Newton originally thought that like an apple or a ball, all objects should fall to earth. However, based on his study of centripetal forces, he was able to explain why this does not happen. When a body A is in circular motion around another body B, it experiences a force directed away from the center of the circular path, which is equal in magnitude and opposite in direction to the centripetal force. This prevents the two bodies from moving towards each other due to gravitational force of attraction between them. This is the reason that the moon and the planets revolve in their respective orbits instead of falling on each other. For a better understanding of centripetal force, let's observe a game of hammer throw, an Olympic athletic event. Each thrower swings a hammer around and releases it at a point such that the hammer flies off in one direction. You can observe that the hammer gradually gains velocity as the thrower swings it around, and the hammer flies off in a straight line which is tangent to the circular path of its revolution. While the athlete is swinging the hammer, that is, the hammer is in revolution, its direction of motion and hence its velocity changes continuously. This change in velocity produces acceleration on the hammer. This acceleration is directed towards the center of its circular path. Acceleration directed towards the center results in a force directed towards the center. This force is called the centripetal force, which means a center-seeking force. The reason for the motion of the moon around the Earth is similar to that of the motion of the hammer, just discussed. The gravitational force of attraction between the Earth and the moon provides a centripetal force for the moon. In the absence of centripetal force, the moon would follow a tangential path similar to that observed in the case of the hammer discussed. In that case, our moon would have flown away from the Earth long back.